This is a tech demo for TestEase, a modular testing program used for the Modbus protocol that solves a real-world problem for Hitachi Energy, which wanted to test transformer registers, the discrete coil input and holding registers for different values by simulating them without having to do it manually. So this is a little tech demo on that. So discrete and coil inputs can only be true or false. And you can see that here. That's the only options you can configure them to. But input and holding registers are where things get interesting. You can do things like this. For input or holding registers, you can change their name and you can change the values that they hold from fixed or a range of values. So first we'll do a fixed value, just a regular fixed value. We'll set that as 5. Just leave that fixed. We'll see that that is 5. And then we'll go to the next one and we'll say that this is going to be a float. We're going to say this is a fixed float. We're going to change that to a float value. And for Hitachi Energy and for the Modbus protocol, float values are not actually supported. So what you have to do is convert them to two shorts. So we made a little generator for that that would just convert two arrays. It would create the two arrays needed for those shorts out of one big float. So we have that. That is a float now, and that takes up two values, obviously, because you need two values for the floats. We'll go to address 5. We'll change this now. So that's everything for fixed. Now the range is where it also gets interesting. We'll have a linear range going from 0, change the value to 100, and we'll increment every 5. So we'll go up by 5 between 0 and 100. Fixed. Linear. Segment. And now you see it's going up by 5. We'll see that later. We'll take a look at that later. Now let's take a look at a curve. Say the same bounds. Now this is how many times it's gonna um complete the curve in a certain period. So just to see the curve more pronounced, we'll make a bigger number here. We'll do like 12. So now it's going in between 0 and 100, and it's gonna have 12 intervals in between that period. So period is going to, from, and back. We'll go to number 7, and now we can do a random value. So this is another thing that Hitachi asked for, where you just specify a range and it'll do random values. So this is good for testing edge cases of just randomness. So now that's all random. So now to actually see this in action, we'll go to a third-party tool. These registers. So we're looking at register, holding registers. Look at the first one, and that should just be 5. So as you can see, it'll just show 5. And now for the next one, since that was a float value, we'll go to address number 2. This is also 0 index, right? So this is address number 2. And we'll turn this into a float value. So that is how you see. As you can see now, the float value shows up as 5.2, even though it's actually showing going to be pushing these two short arrays out, but Modbus obviously reads it as a float when you do it like that. So now let's see some curves. We'll go to address number 5. So now you can see some randomness and some data generation. So what we're gonna do is we're just gonna scale this automatically. Okay, so the green one is so the light teal one is the linear one. It's going up by 5 every time. As you can see, it's going from 0 to 100 at intervals of 5 linearly, and then it goes back. And then the lime green one was the curve. This is a sine curve that has um 12 intervals per period. So as you can see, it's going to have 12 of these steps per period, which is up, down, and a period of a sine wave. And then the yellow one is random. As you can see, it doesn't actually have a set pattern. It's just going to random values. So this is a data generation that we created for testing purposes of Modbus, and this helps the Hitachi engineers significantly. And now I'll just show you a little bit more that we baked in so that it's easier for them to use this on a daily basis. So what they asked for is so that they're going to have a bunch of different testing scenarios where they have different registers up. So that was just one demo scenario that we had. And um, you can exit out of this. Obviously, you can just completely clear it out quickly. And what you could also have done is you can take saved configurations like this that was already saved on the system, and you can open them back up and it'll populate all the registers with that saved information. So this saved information was also told to us to be human readable. So we created it and turned it into a JSON representation, right? So all of these models, they'll tell you the type of register it is, the value in it, and anything you need to recreate it. And our system takes this in and repopulates everything just using human readable JSON. And then, as you can see, that's just populated into the user's directory. And then you can go in and rechange anything you needed. And yeah. So another thing for ease of use is we created this where you would show only configured registers because you can have 65,000 entries in here. And another reason we added, since there's 65,000 entries, we also added this quick use address bar so you can just jump around to whatever you need and it's all super quick. Um, yeah, I'll just go back to the beginning. Yeah, so that is Modbus. And as you can see, that was just one server, but you could have multiple servers running. You could have on different ports. We just have it defaulted to starting at 502. And all of these could have different configurations running. And they could all be doing it concurrently, as you can see. So let's go ahead and turn that off. And another thing that was in the project description was an MQTT broker. A broker is just pretty much an ability for the Modbus server to be able to talk back. Um, so for that, this is another third-party tool that you can use to do this because Modbus is proprietary, so you have to use third-party tools to test. So we'll just try to connect. Boom. So now oh, we have to first turn on MQTT server, of course, and then you connect to the server. And as you can see, it now shows the client here. And that client can go ahead and add a test. Say yes, yeah. And now the server will see it. So now clients can talk to the servers, servers can see the clients, you can see how many messages are sent by each client, the uptime for each client, and if a client sends a bunch of messages, because obviously this would be populated by a bunch of logs and whatever the system wants to convey to the engineers. So now you have a bunch of things in there, and if you wanted to find something quickly, you could filter by that and you could find it. Find C or D or E or when did we do all of that? And then you can delete messages as you see fit or clear them all at once. So that's the MQTT functionality, being able for the client to talk back to the server and for the server to be able to see information about the clients. Then, as you can see, as the client's disconnected, updates in real time, turn that off. And now another thing that we have is dark mode. They also ask for a dark mode. So you can switch between light mode, which you have been seeing, and dark mode. And then this is what Modbus looks like in dark mode. I personally like this better. As you can see, once you change a value, so you can see we also have error handling. That makes it green. And then for float values, changes that color as well to the dark green for the secondary input. Also, by the way, once you do a float, you can't click onto that second value because you're not allowed to change that or it would mess up the address on number 6 because it needs both addresses to work for a float. So yeah, as you can see, we have error handling all throughout. We have concurrent addresses. We have concurrent servers running. We have an MQTT functionality, the broker functionality for it to all talk together. And yeah, this shows full stack experience, concurrency. This is on .NET MAUI, which was a relatively new multi-application user interface. That's what MAUI stands for, language. And yeah, thank you for listening, and I hope you enjoy.